Welcome back to 9C, lesson 9C on calculating calculations involving equilibrium constant. Right, example 6, a mixture of 0.25 mole nitrogen monoxide and 0.1 mole bromine is placed into a 250 cubic centimeter container. I think the cubic centimeter is going to be a problem. We will need to divide that by 1,000 to change it into cubic decimeters. So it's sealed off at a temperature of 400 Kelvin. The balanced equation for the reaction is 2 moles nitrogen monoxide plus 1 mole bromine goes to 2 moles nitrogen monoxide bromide. I don't know how to pronounce that. Equilibrium is reached after 10 minutes and it is found that there are 0.2 mole nitrogen monoxide present. Calculate the equilibrium constant at this temperature. So we write down the balanced equation and we write down, we take note that everything is gas, gas, gas. Then we write down our mole ratio, 2 moles to 1 mole to 2 moles, because this is the ratio in which the reagents will react. What did we start off with? 0.25 mole nitrogen monoxide, 0.25 at the start, and 0.1 mole of bromine, and obviously we must have started with 0 mole of NOBr. What was used or formed is what we will figure out a bit later. Then what is there at equilibrium? Right, at equilibrium there are 0.2 moles of nitrogen monoxide. I don't know the amount of bromine that will be present, and I don't know the amount of NOBr that will be present. Those are the things we need to figure out. We know how much nitrogen monoxide we started off with, and we know how much we ended off with. So we can calculate the amount that was used. So 0.25 minus 0.2 is 0.05 mole that was used. Then we're going to use the ratio. 2 moles of nitrogen monoxide reacts with 1 mole of bromine to figure out what the amount of bromine would be. So the amount of bromine, the ratio is 2 to 1. So I have to divide this by 2 to get the amount of bromine that was used. So I think this would be 0.025 moles. If I've got that, and I've got what I started off with, and I've got what I used, then it's not too difficult to calculate what was at equilibrium. So it is 0.1 0.1 minus 0.025, and we get 0.075 mole of bromine at equilibrium. Now, last step is to figure out how much NOBr was formed. That can't be too difficult, because the ratio between the NOBr and NO is 1 to 1. 2 to 2, same as 1 to 1. So that means that 0.05 mole of NOBr was formed. I started off with nothing, so this is 0.05 mole. Our next problem is to change the moles into equilibrium concentration. Now, 250 cubic centimeters is 0.25 cubic decimeters. So I have to divide that by 0.25. I have to divide this by 0.25, and I have to divide this by 0.25. If we do that, the mole per cubic decimeter concentrations at equilibrium, 0.2 divided by 0.25 is 0.8. 0.075 divided by 0.25 is 0.3. And 0.05 divided by 0.25 is 0.2, and it looks like this equilibrium is lying to the left. So the Kc is the concentration of NOBr to the power 2 divided by the concentration of NO to the power 2 times concentration of Br2, and we get 0.2 squared divided by 0.8 squared times 0.3, and it gives us an answer of 0.8 squared times 0.3, 0.208, 0.208. Right, so the equilibrium lies to the left. Just for the sake of time, I'm going to do the next two exercises on the next video, so I'm going to stop it here.